The next category is the model-based learning. So in model-based learning, we have a similar situation in which we have some instances belonging to different groups or classes, and we have some new instances, and we want our model to generalize to the new instance, right? So in this case, we want to train a whole model, and we want that model to predict perfectly or more accurately on to the new instances, so that we can perform prediction on the new instances. So in model based learning, which is another way to generalize from a set of example, right? So in this case, we try to build a model out of these training examples, right? And once we have this model generated, we want to use this model in order to make predictions, right, on the unseen data. And this predicting the on unseen data is also known as inference, right? So mainly we have two different steps here. In one step, we are basically training our model so that our model can learn from the data, and then on the second step, which is the inference step, we are making the prediction, and we are trying to our model is trying to predict correctly on the unseen data set, right? So once we have these two things, we can hope that the trained model can have the generalization capability, and it will have the capability to make predictions on the unseen data perfectly during the inference stage. And we will learn more about it in the next session. We will have a whole complete session on this thing, and we will see that how models can be trained and how inference can be generated from them. Okay, so far we have covered the basics or the fundamentals of the machine learning in terms of their types, right? So we have seen that what are the different types, and what are the different learning mechanisms, and how can we basically improve or select different learning domains based on our objective or our application. So now the next thing is to see that what is the basic pipeline of a machine learning algorithm, right? We have talked enough about different categories, and we have talked enough about the general concept, but now it's time to dig deeper into the basic functionality of an algorithm, right? So initially, in this introductory session, we will see the generic pipeline or the general pipeline, which is mostly followed by all of the machine learning algorithms, right? Because all the machine learning algorithms have some commonalities in them, and there are some common steps or common modules, or you can say some common components, which are being followed by almost all the algorithms. And we will in this introductory session, we will see that what each component is doing, what is the purpose of each component, and how each component is playing a role in the training and the prediction step, right? And then when we will move on to the algorithms, and when we will be discussing each algorithm step by step, then we will see that how these basic steps which we are discussing now are playing a role in each algorithm. Either it belongs to supervised learning, unsupervised learning, or either it belongs to reinforcement learning, but we will see that all of these steps are basically involved in all the algorithms. So here is in this figure, you can see that there are 5-6 major components or major steps which are involved in a machine learning pipeline, right? So the first step is the data gathering or the data collection step. So independent of any application, it doesn't matter that which application you are working on, you will have some data set in that, right? But that data set can vary in terms of its type. For example, if you are working on an application that is related to some medical data, then in that case you will have some medical images, right? In that case, you will have the data set in the form of images, right? On the other hand, if you are working on a surveillance application, for example, then in that case your data will be in the form of videos, right? Now on the other hand, maybe if you are working on some applications in which you require the audio input or audio signals, right? So in that case you will have a one-dimensional data in the form of signals or 1D signals, right? So the type of data can vary, but in any machine learning application you will require some certain type of data, right? So the very first component of your machine learning application is the data gathering or the data collection, and you need to collect data from maybe a single source or maybe from multiple sources. So once you have that data, then the second step is to perform some pre-processing steps on that data, right? So pre-processing means that you need to uh, do some cleaning on the data. Maybe you need to do some you need to remove some values from the data, because once you gather the data, for example, if you are gathering the data from some sensors, then it can happen that data is not in a very good form. Or maybe if you have some images, maybe there are some bad lighting conditions or some noise in the images. So all these challenges or hurdles which we have in certain types of data, we need to overcome that, we need to remove that in the data pre-processing step. So there are a number of modules can be present in the pre-processing steps which help us to clean and remove the noisy data. So the basic purpose of the pre-processing is to improve the shape of the data and to clean the data so that we can extract features from it. So the third component is basically to extract the useful information out of that data, right? So we employ different strategies, we employ different types of algorithms here, and we do some feature engineering on the data, right? So the basic goal or the ultimate target is to extract some certain features from the data so that we can provide those features to the algorithm or model so that our model can learn on those features. Now again, these features are can be different depending upon the data, right? So if it is a imagery data, the features will be different. If it is an audio data, the features will be different, right? So in different types of data, our features will be different, and even in the like depending upon the application, the features could be changed. For example, if I want to build a surveillance application and I have a number of individuals in my data set, then maybe I will be looking into different features of a human face, through which I will be able to recognize them, right? But if I have some textual data, then I will be looking into, maybe if I am doing some stock market prediction, then maybe I will be looking into different predictor values, and those predictor values will be the features in that case. So the third step is to extract useful features from the input data set, which is in the cleaned form. And once we have all these features, we basically provide it to our model or machine learning algorithm, and our model is trained on these features. So it tries to figure out the patterns or the characteristics, so that it can learn that which sample belongs to which class, maybe, right? So after extracting features from the data, we provide it to our algorithm so that our algorithm or model can be trained on that data set. And once the training is complete, our model is completely trained on the whole training data set, then the last step is to make predictions out of that model, right? So here in this step, we basically provide unseen instances or unseen data to our model, and our model, based on its training, tries to predict the classes or the values of the unknown entities. So this is basically the target of the prediction. But you can see that there are 5 major steps, and you will see that almost all of the machine learning applications will follow the same pipeline in their execution.